So we're going to take the row total times the column total and divide by n. The row total is 40 times 70. Oops, sorry. Okay, so that's going to be 40 times 70 divided by 200. So that's 2800 divided by 200, and that's going to be 14. So let's go here. That'll be 14. Now, to check yourself, when you think you've completed the table, be sure you add down. These have got to equal 70. This row has to equal 88, 42, and then they have to add across as well. So I was just mentally a second ago adding these up just to approximate. So 45, 65, oh wait, no, I'm sorry, 45, 55, yeah, about 70, okay? I mean, you would do it exactly. And then let's see, let's do one across. 21, that's about 47, and about 13, so that's 60, okay? So be sure you check that it adds across and adds down, and then the totals should add to 200, and the totals across should also add to 200. So this whole table is the F sub E's. Okay, so here we have the F sub O's, and then here's the F sub E's. Okay, now, for each cell, we are going to do the same formula that we did in chapter 12.1, where F sub O minus F sub E squared over F sub E. Okay. And then we will add up all the cells. We're going to calculate this for all the cells, and then we're going to add them up to get the chi-square calculated. Okay? So, let's go back here. Let's take the top left-hand quadrant, and so that is 24 is observed. 24 minus the expected is 24.5 squared over 24.5. Okay. So that's going to be 0.5 squared over 24.5. So that equals 0.25 over 24.5. Which you could see is going to be a very small number. Now, if you add up all of the oops, not chi-square F, sorry. All of the calculated statistics for each cell in that table, then, and you should go ahead and calculate those, then that equals 0.709. So you can see that the total is 0.709. The entry in each cell is going to be a very small number. You'll want to calculate to 4 or 5, maybe even 6 decimal places each cell, and then you should come up with about 0.709 for the calculated chi-square. Okay, so that will give us our test statistic of the calculated chi-square. Now, to get to the critical value of chi-square, we're going to need the degrees of freedom. and we said that was R minus 1, or C minus 1 times R minus 1, or vice versa. And let's see, we had 3 columns, the 20 meals per week, 10, and none. And then 4 rows, freshman, sophomore, junior, senior. So that's 2 times 3 equals 6. So 6 degrees of freedom. Let's say alpha is 5%, one-sided test, two-sided distribution. So let's look on page 796 for the critical value. Page 796. The critical value at 5%, which is the fourth column from the right, and 6 degrees of freedom, and that will be 12.592. Okay. Now, then we'll see if we reject the null hypothesis or not. Okay. The critical value of chi-square is 12.592, and the calculated chi-square is, we said, that very small number, 0.709. Okay. So our conclusion is we do not reject the null hypothesis. We do not reject the null hypothesis. Okay, the null hypothesis was that the variables are independent of each other. We do not reject that null hypothesis, so the variables are independent of each other. Now, why does that matter? Because if you're marketing for the university for the food plan, and you need, and the variables were dependent on each other, then that would mean that, for example, if you're a freshman, you would be more likely to have, let's say, the 20 meals a week. If you're a senior, it would mean, for example, you're more likely to have no meals a week. But our conclusion is that these are independent of each other. So you could market to the entire population of students. Whereas if we had rejected this null hypothesis, we would say, okay, the number of meals and the class are dependent, and you might market for freshmen and have different marketing for seniors, juniors, sophomores. Okay. And then finally, our homework, page 482. Problem 12.24, and the alpha is 0.01. Thank you.